Understanding collisions in hash tables.
Hash tables are efficient data structures for storing key-value pairs. However, sometimes two keys hash to the same location, causing a collision. To handle these collisions, programmers use different strategies to ensure data integrity and quick access. Let's explore the two main methods, separate chaining and open addressing, and see how they work.
What is separate chaining?
Separate chaining uses linked lists or similar structures at each hash table index. If multiple keys hash to the same index, they're stored in a chain at that spot. When searching for a value, the key's hash is used to find the right chain. Then the list is searched for the exact key. This approach is simple and effective, especially when the table isn't too crowded.
How open addressing works.
Open addressing does not use extra structures like linked lists. Instead, if a collision occurs, it looks for the next available slot in the table through a process like linear probing, quadratic probing, or double hashing. Each key remains directly in the table, making lookup and storage compact, but sometimes requiring more work as the table fills up.
Trade-offs between the techniques.
Separate chaining can efficiently handle high numbers of collisions, but may use more memory for lists. Open addressing keeps data in the table, but can become slow if the table gets too full. The choice depends on expected load, memory constraints, and the need for simplicity versus speed.
Choosing the right collision handling method.
If your dataset might grow unpredictably, separate chaining offers flexibility. For situations where keeping memory usage minimal is vital, open addressing may be better. Understanding these methods helps ensure your hash table implementation is both reliable and efficient for your specific use case.